Mr. Ross, back at you again.
And Flynn.
Yes, and so we're working on this modeling task. This is part 2. We had gotten so far as to using Excel to compare two graphs numerically. We'd only looked at our graph that we made, our function we made.
Well, we could really quickly copy some of the stuff and look at the graph that the technology made.
Right, so look at the graph, you mean, or the...
I'm sorry, not the graph, the equation.
Okay, so here's the one that technology made.
All right.
Okay, I scanned it down there, and now let's do the same kind of analysis down here. So
we'll just call it tech model.
Call it tech model. And so similarly, we're going to, let me change the screen so I can see it better. Okay, so
equals.
Equals, I want to make it a little bit bigger. Control all, let's make it bigger. Old man eyes, okay. So we're here, we're going to equal to, our model here says, on the bottom,
0.2829.
2829.
Now instead of x again, don't forget we're looking at our variable, our independent variable, which is time. A2.
And then we plus 0.028863.
There's our equation.
There's our equation, and that's our value.
Drag her down.
I love this part.
So much fun.
It's fun to do. Okay. Then
might as well go ahead and look at the difference again.
So we do absolute
yeah,
difference
let's
right
just
off the bat?
skip ahead.
Do absolute difference. So we're going to equal to
absolute
of the different, no, I want, which one are we doing again? We're doing distance.
It's the model, or the original.
Right, minus our model.
No, technology model.
Oh, right. That's easy to fix. Let's fix that to the tech model. That's the one it should be. There we go.
G2.
G2. Enter. Oh, not much of a difference there at all. Drag it all the way down. There you have its values.
All right, and of course I always like looking at percents.
Percent error. So we go equal to, we went
absolute difference.
Absolute difference divided by the
our
actual
model.
value.
Oh yeah, that's like my actual value.
Times 100. Enter. And we get that percent. Okay, well, come on. Okay, we get all those.
Well, let's just go ahead and
Let's just steal this. We'll drag over the sums. This value doesn't make any sense. But here are some sums that we have.
so by looking at our percent error and the sum, actually,
let's steal this value and put it into here so we can write about it if we want to.
okay.
Okay, here's what the table says, right? Okay, now what? Making sense of this.
All right. So this was our percent error here
For
of our model.
Right.
And here's the percent error of the technology model.
Well, just based on those numbers, from the graph we looked at it, they look both the same to us.
Mm-hmm.
But here we can see that clearly the tech model has lower percent error, so it is probably the better model.
Yeah, the tech model has lower percent error.
Right. So that would probably be the one you choose. Now, it is possible that when you do this that your model might end up being better, and that's okay, as long as you justify it. Okay, let's go back to our Word document and see what it had said next to do. So we had choose best model, we explained, and then the next part is to predict the location when time is 50 seconds.
Using the best model. So
Using the best model.
in this instance, it would be our technology model. So
Right.
using that technology model, well, that's easy to do. Time is 50 seconds. That's just our x value, our independent value.
Right.
Plug it into the equation, solve.
Good. And then the other way around says, what's the best prediction? But use your best model again, the tech model in our case. What time will it be when you're 3 meters away?
And this is a good opportunity that you're actually showing your work, you're using math type because we have that available to us on our Word document,
Right.
showing all your work and your steps neatly, explaining as you go along.
Right. And so here's what the write-up you're going to do. Have an introduction, define your variables, discuss constraints. Variables are just whatever you use for X and Y. Make sure you define them.
And what the constraints, just what makes sense. And does time mean negative? Makes sense.
Yeah, you should talk about that. Show your data in a table. That's easy to cut and paste. The scatter plot, you just get a screenshot of the autograph. Your calculations for line of this fit your model. Then you show the line of graph scatter plot, a screenshot here, and think about what you see. What does it fit the trend? Is it a good model?
A lot of this is just communicating as you're moving through this whole process that you're communicating it.
Right. And we're looking at the data, the equations, the graphs, and your words, linking them all together.
Yeah. So a nice flow to the whole project.
Exactly. And then you just follow these steps.
Write your conclusion.
And then you're done.
Not so bad.
Not
Got
so
quite a few
bad.
days. About a week to
About a
finish
week.
this.
Yep. Work hard.